So now we move on to local max and local min values. And we have 0 and 2 to be concerned with. There's my function. There's my function. Get up here. So f of 0. F of 0 is 0 from here. So local max or min. Looking here, I can see it's a max. Local max at 0, 0. And then we have f of 2 is what? Something unpleasant. Times -3. Okay, so if this happens on a test or something, we will give you the number. This one's roughly minus 4.75. And that's a local min. Local min at the point is 2 and negative 4.75. Okay, so G, concavity and inflection points. Okay, I stashed my second derivative down here quite cleverly. So f double prime equal to 0. How is that going to happen? Well, the numerator must be 0. So x has got to be -1. We should be concerned about where f double prime doesn't exist. Because our next thing we're going to do is we're going to do this number line thingamabob. And concavity can change at a point where the second derivative doesn't exist. So we've got to watch out for that. So we'll keep that in mind. F double prime of x does not exist when x is 0. So this is strange. This is not, x equals 0 is not an asymptote. But we are going to include it on our number line here, because as we're going to see, the concavity could change. So we got -1 and 0, and we start plugging in test points, so say -2. The denominator is always positive, because this power of 4 here makes the denominator always positive. So if I plug in -2, I'm going to get negative. So concave down. And then if I plug in something, say -1/2, look at my numerator, I get plus on top. So plus overall, concave up. And finally, if you choose something bigger than 0, you get positive over positive, giving you concave up again. Inflection points. The inflection points. Let's see. F of -1 is going to be -1 to the 2/3 times -1 minus 5. You'll recall that -1 to the 2/3, that's -1 third, and then square, which is -1 squared, which is +1. so -6 down here, giving me the IP that I get here is -1, -6. F of 0 is just 0, giving me an inflection point 0, 0.